Welcome. This is Algebra 1B Part 1. We're going to do the sample work vocabulary for Unit 5 on quadratic equations. Go ahead and write, get out a sheet of paper and write each word, each definition, and sketch each example. All right, so here we go. Number 1, quadratic equation. An equation with whole number powers of x where x squared is the highest. So examples, x squared equals 5, 2x squared minus 8x plus 3 equals 0. Those are some examples. 2. Okay, substitute. Replace a letter with a number. So example, x squared plus 5x plus 2 equals 0. Replace x with 3, would look like 3x squared, 3 squared plus 5 times 3 plus 2. Okay, equals 0. Replace the variable with a letter, or the variable with a number. Evaluate. Three. Substitute and simplify. So in our previous example, we would take x squared plus 5x plus 2 equals 0. Replace x with a number like 3. To simplify equals 0. 3 squared is 9, 5 times 3 is 15. And 9 plus 15 plus 2 is 26, which does not equal 0. That's false. So 3 is not a solution of that particular quadratic equation. Evaluate. 4 satisfies. Makes a true equation. So in the example, x squared plus 5x plus 6 equals 0. Negative 3 satisfies it. Negative 3 plus 5 times negative 3 plus 6 equals 9 minus 15 plus 6 equals 15 minus 15 equals 0. And so it makes the equation true because it equaled 0 to begin with. Satisfies. So satisfying. Number 5, inspection. Solve in one step in your head. X plus 2 equals 5. By inspection, x equals 3 because 3 plus 2 equals 5. Inspection. 6, perfect square. A number multiplied by itself. Perfect squares include 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. In quadratic terms, a perfect square would be x plus 2 squared equals x squared plus 4x plus 4. That is a perfect square because it can be represented as the square of a binomial. 7, square root. Answer to the question, what number squared equals this? The square root of 9 is 3 because 3 squared is 3 times 3 is 9. Square root. 8, factor. A number multiplied by another. 2 times 3 equals 6. 2 and 3 are factors. Nine. Product. The answer to a multiplication problem. Six there is a product. Okay, let's move this. I like to move it, move it. Okay, number 10. Zero product property. If a product equals 0, then one of the factors equals 0. Example, if x plus 2 times x minus 3 equals 0, that is because x plus 2 equals 0, or x minus 3 equals 0. (11) Factored form. Writing a product as a multiplication problem. X squared plus 5x plus 6 can be factored to x plus 3, x plus 2. That's factored form. Root of a quadratic equation. A value that makes the equation true. X squared plus 5x plus 6 equals 0. The roots are -3 and -2 because they make the equation true. (13) Greatest common factor. Otherwise known as the GCF. It's the biggest number dividing evenly into 2 or more numbers. The greatest common factor of 20 and 25 equals 5, because 5 times 4 is 20, and 5 times 5 is 25. So 5 is the biggest number that divides evenly into both those numbers. Okay, 14. Shared binomial. When a binomial is a common factor. So if I have x times x plus 4 minus 5 times x plus 4, x plus 4 is a common or shared binomial, and it can be factored out like this: x plus 4 times x minus 5. 15. It's time to move it, move it. 15, standard form. For a quadratic equation, it is to write it in this form: ax squared plus bx plus c equals 0. So an example of a quadratic in standard form is 4x squared minus 5x plus 3 equals 0. Note that it starts with an x squared, followed by an x, followed by a constant, and it equals 0. We need to have it in standard form before we try to factor it or use the quadratic formula. 16. Sum product pattern. When factors of the last term add to make the middle term. X squared plus 5x plus 6. Factors of 6 are 1 times 6 and 2 times 3. But 2 times 3, 2 and 3 add to make 5. And they add to make 5, so this factors to be x plus 2, x plus 3. 2 times 3 is 6, and 2 plus 3 is 5. Sum product pattern. 17. Perfect square trinomials. Anything of this form: x plus a squared equals x plus 2a plus a squared. Example: x squared plus 6x plus 9 can be written as x plus 3 squared. 6 is 3 plus 3. 9 is 3 times 3. So the sum product pattern is that it's the same number added and the same number multiplied. It makes a perfect square trinomial. Difference of two squares. Anything of this form: x squared minus a squared equals, and actually let me give it the general term, a squared minus b squared equals, don't need the parentheses, equals a plus b times a minus b. Example: x squared minus 25, which is 5 squared, x squared minus 25, or minus 5 squared, equals x plus 5 times x minus 5. Literal equation. An equation relating two or more unknowns. Example, y equals mx plus b. Or I used a squared plus minus b squared equals a plus ba minus b. Why don't I use that? That's even better. A squared minus b squared equals a plus b times a minus b. That's a literal equation. It uses letters instead of numbers to relate or give a relationship. 20. Formula. A literal equation solved for one unknown. Let's try this without the bar here. Okay, example, a equals pi r squared, where a is the area of a circle and r is its radius. It's a formula. 22. Parabola. A U-type shape from the graph of a quadratic. Y equals x squared, for example, goes through 0, 0, 1, 1, and 4, 2, 4. It makes this U shape. Like that. Parabola. 23. Time to move it again. 23, and time to move my other screen. Axis of symmetry. A line dividing a parabola in half. Example, this line right here, which is, for this particular equation, the line x equals 0. Vertex. Intersection of a parabola and its axis of symmetry. Example, the point 0, 0 right here. Vertex. 25. Zeros. X values that make the function equals 0. It's also known as the x-intercepts. So for y equals x squared plus 3x plus 2 the values -1 and -2 are zeros because it crosses at -1 and -2. The graph looks like this. This is -1, 0, and -2, 0 actually, and -1, 0. Okay, zeros. 26. X-intercept. I'm just going to say C zeros. It's another word for the same thing. 27. Y-intercept. Y-intercept is where a graph crosses the y-axis. Consider the quadratic equation. X, I'm going to write it in this form, y equals x minus 1 squared. Yeah, just x minus 1 squared. Looks like this. Here's the origin. It's moved over 1, and it crosses right here. Okay, and its y-intercept is right here. Y-intercept is 0, 1. It's where it crosses the y-axis. All right, that's it. Good list.